Welcome to the multivariable calculus section. In this section we'll be discussing double integrals over a general region. So last lesson we discussed double integrals over a rectangular region. Now we will discuss how to compute double integrals over the general region. So in a general region we are no longer provided the luxury of calculating volume through adding rectangular prisms. So we have this equation. The volume is approximately equal to the double integral of f of xy dA. So similar to single variable calculus, there are two cases that we must address for the general region. They are both depicted in text and in graphical representations. So here we have case 1. So in case 1 we would want to integrate from top to bottom, or from bottom to top, vertically essentially. However, in case 2, most of the time we would want to integrate this region horizontally. So what we do is we have two separate cases. So essentially in case 1, the integral that we would be using is as follows. We would state that the integral over the general region D of f of xy is equal to BA and g2 of x, g1 of x, f of xy, and we would be integrating with respect to y first and then x. Now this is case 1. Let me reiterate that. Now in case 2, what we'd be doing, we'd still have the same left-hand side. We're still taking the double integral of the region D with respect to dA of f of xy. We are still, but our right hand changes. We are going to say that dC with respect to h2y, h1y, f of xy, dx dy. Now this time we will be integrating with respect to x first, because we want to essentially draw our figurative rectangles as follows. We want to say, okay, we want to integrate from here, and then here, and then here, whereas in case 1 we would want to integrate from top to bottom, or bottom to top, or vertically. So now there's important properties of double integrals that are important to discuss. That now there is an additive property claiming essentially that the double integral over a region D of f of xy plus g of xy dA is separable, meaning that we can say we want to take the double integral of f of xy dA and add that to the double integral of g of xy dA. Additionally, if we have a constant, like all integrals, we can pull out the constant on the outside and say we just want to integrate the function with respect to dA. So that is it for double integrals over a general region. I hope that helps. There's a bunch of problems on the website, and if you need additional assistance, that is provided as well. Thank you.